Dr. Jeff Karp is a professor of medicine at Brigham and Women's Hospital at Harvard Medical School. He is also a principal faculty member at the Harvard Stem Cell Institute and an affiliate faculty member at the Broad Institute and at the Harvard MIT Division of Health Sciences and Technology. He works in the fields of drug delivery, medical devices, stem cell therapeutics, and tissue adhesives. He has published over 125 papers with nearly 22,000 citations and has given over 300 invited lectures. He has over 100 issued or pending national and international patents. Moreover, several technologies developed in his lab have led to multiple products currently in development or on the market. Karp has received more than 50 awards and honors. In addition to his research goal, Karp is dedicated to developing the careers of the next generation bioengineers at the forefront of regenerative medicine.
Hey, how's it going?
I have always been very curious about a lot of things, and my dad was very into science. He is a dentist. He retired a number of years ago, but he also has, and that's probably where I got it from. He's been very curious, about a lot of different things. I got his old microscopes when I was young, and I had no idea what I was doing, but I was just kind of playing around with them and looking at various things. And I never really did any experiments per se. It was more just exploration. And when I was going through school, actually I struggled quite a bit in school. And then I was identified as having a learning disability. That was when I was in grade 7. And I switched classes from one teacher to another. And the teacher that I switched to was actually the main science teacher for the school, Mr. Couch. And he was incredibly inspirational. And that was really, I think, one of the big reasons why I got into science. In fact, for the learning difference that I have, I was able to get extra time and kind of write exams in a different place or tests in a different place than everybody else. So I used to spend time in the back room of the class. And in that room, there was a lot of chemicals and skeletons and things. And I used to just kind of look around at them and was just amazed. And so I think it was really in elementary school that I got excited about science. And then when I was in the 3rd grade, I moved out to the country, and there was a buffalo farm across the road from me, a sheep farm beside me, a big farmer's field in our backyard that we rented out to a farmer. There was a forest and there was a creek. We used to get all kinds of different animals like foxes and deer and snapping turtles. And there was, in the creek, there was crayfish and all kinds of great stuff. So, I think that to a large extent is kind of where my love for science came. And then in particular with drug delivery, I mean, I really didn't know anything about drug delivery probably until my last year of my undergrad at McGill, where I took a couple courses. Actually, I extended my undergrad. I applied to medical school, and then I was rejected from all the schools I applied to. And then I decided to spend an extra year at McGill to take some physiology courses so I could get into these upper level courses that I thought were really exciting. One was on artificial cells and immobilization biotechnology, and another one taught by TMS Chang, who's one of the kind of grandfathers of the field of biomaterials, with artificial blood substitutes is one of his main sort of research areas. And then I took another course, which was more about tissue engineering. And that's where I started to learn a little bit about drug delivery. And then it wasn't until I went to grad school at University of Toronto that I really was able to kind of get into that space. I didn't really work on drug delivery per se, but there were a lot of people in the labs. I had 2 advisors, Molly Shoykett and John Davies, and there were people who were doing controlled release experiments there. And that's where I really got to understand what that was all about and how that could be useful. A big turning point for me was when I got into Bob Langer's lab at MIT. I was moving along in my PhD, and I just really loved research. I had done some research in my undergrad for a couple summers in a bacteria lab. And so I emailed Bob, and I knew that he had many applicants to his lab. I think at the time I was told it was on the order of 2,000 or 3,000 a year. So I spent a long time writing that email, and I wrote in the subject line a postdoc candidate with big ideas, and the word "big" in caps. And then I told him about two problems that I wanted to solve. One is celiac disease, because I actually have celiac disease, so I'm gluten free. And then there was another one. I forget what the other one was. The last statement I wrote in that letter said, Ali Kadamuseni, who's a good friend of mine, who I met in grad school at U of T. Ali got his master's in Toronto, and then went to do a PhD with Bob. And I started with the master's, but then bypassed the PhD, so I stayed in Toronto. So I wrote it in the last part of that letter. Ali Kadamuseni can attest to my hardcore enthusiasm for science. And so Bob, got my email, and he went and talked to Ali. Ali put in a good word. Thank you, Ali. And but then Bob came back to me and he said, you have a strong record, but we're unable to bring you on because of funding. So I thought about it, and I was like, it's possible he's just saying that, so that I would go away. But it's also possible that everything he was saying is truthful, and that if I had funding, that he would take me. And so I opted to think the latter. And so I wrote him back immediately, and I said, if I get my own funding, would you take me in your lab? And he said yes. And then I wrote back and asked him if he would put that in writing. And the reason is because at the time I was applying for a Canadian fellowship to support my postdoc, which was a very generous fellowship from the Canadian government that paid $40,000 Canadian per year for 2 years, and you can go anywhere in the world. And it was back in the day when there was a paper application. And so Bob said, sure. He wrote back right away. I got the letter, I added it to the back of my application, and I submitted it basically saying, if you give Jeff this fellowship, then I'll accept him in my lab. And so, and that's exactly what happened. I got the fellowship. I heard, many months later, and then I wrote back to Bob to make sure that the offer was still on the table, which it was. And that's how I got into his lab. And that was a huge turning point for me. Because his lab is just filled with incredible people with incredible diversity in terms of their expertise and where they're from, and everybody really wants to be like Bob. So everyone is really going for massive societal impact, and it was truly a playground. Now I will say that it wasn't easy from the perspective that that I'd say I wanted to prove myself. And so I had to work very hard, and I had to really think critically and develop strategies for how to maximize impact in the lab. And initially I decided I would focus just for 1 year on an extension of something that I knew about. And then after that 1 year, I was going to do absolutely nothing I had done before. So take some major risks. And so that was really a turning point for me. I think that tools are more accessible than they've ever been before. It's almost any lab can make nanoparticles or microparticles. Back a number of years ago, it was only select labs that could actually do that. And now you can do it in any lab, just based on the availability of tools and the low cost to purchase those tools. And I think this goes far beyond just manufacturing of particles. I think, doing analysis and various ways of making materials. So I think that, it's safe to say that tools are more accessible than they've ever been. I think also important to consider that there's an unlimited number of problems to solve. In fact, I think as we go on with civilization, that one thing for sure is that humans will always create more problems than they solve. So with that said, I think the biggest challenge that probably has always existed, and but maybe is even more of a problem moving forward, is that it's very difficult to match the right technology with the right problem, the right solution with the right problem. And I think that it's exciting from the perspective that there's so many things we can do, but there's probably a very small list of things that we actually should do. And to me, but that also is exciting in and of itself, because it's almost like, you need to constantly have your detective hat on to be able to figure out whether the way that others have defined problems is the right way to lead to an appropriate solution, or that you need to go in and conduct some very targeted experiments to gain insights that others have missed or haven't yet uncovered, that could lead to a translatable solution. And I think now is more, it's incredibly exciting because the infrastructure is in place for bringing technologies out of a lab in terms of filing patents and then having those patents be licensed and starting companies and entrepreneurs. There's lots and lots of entrepreneurs, and there's more and more kind of every day, every year, who are gaining more and more experience. And there's companies have matured a lot in the biotech and pharmaceutical and biomedical space, and there's a lot of funders, including foundations and venture capitalists and angel investors and others who deeply appreciate the opportunities that exist within the biomedical community to solve medical problems. And so I think it's a really, really exciting time. There's so many important things that I've learned from other people. One thing that Bob Langer has said, you never want to limit somebody. And I think that, as I think about my mentorship strategy and how I really wanted to, establish my lab and create the right conducive environment for people to maximize their professional development, this is one thing that I've really taken to heart, which is I really try to minimize the limitations on people, minimize the structure, let people really be as free as possible to think and to interact with others. And so, to me, it's totally fine if someone in the lab is collaborating and helping with multiple projects simultaneously. I think there's a balance that needs to be had, because, you kind of want to have a balance of being focused and unfocused. I think both are very important. You never want to be too focused, because then you sort of lose your creative flair, I think, because you're not pursuing your own curiosities. So I think, that this sense of never wanting to limit somebody has been very important in my mentorship strategy. It's a difficult question to answer, because I feel anytime that I felt I've made the wrong decision about something and I try to develop an awareness around it, then that helps me to improve my strategy moving forward. And I think, I'm a type of person where I can certainly learn things from other people to prevent, going in the wrong direction sometimes. But for the most part, I need to really learn things the hard way and have those lessons ingrained in my mind. And so I'm always, in the moment, it's always, frustrating when things aren't going well or not going as you had anticipated. But then usually when I look back in retrospect, I'm glad those things occurred, because they have helped me define a better strategy and path moving forward. So to me, it's a difficult question to answer, because maybe I overthink things a lot, and I always try to flip things around at some point, kind of looking backwards. So I have a lot of things to say about that, but to focus on just maybe one or two. I think one is really to follow and make decisions based on on what excites you the most. And it's always good to get a lot of opinions from different people, but at the end of the day, I think what's most important is not what other people tell you, but rather make decisions so that the choices that you make align most with your passions, and align most with your curiosities, and align most with just what fires you up. And it really doesn't matter what that is. Someone's trying to decide which school to go to, and they really want to go somewhere for whatever reason it is. Could be that they are excited to be in the city, or they're excited about the prestige of the institution, or they're excited about a certain professor who's there, or they're excited because someone they know went there, or really doesn't matter what the motivation is. I think the key is you want to go somewhere where you are kind of perceive every day when you wake up, you're going to be excited and fired up to leave your house and go wherever you need to go to pursue your career and your work. So I think developing an awareness of what excites you the most and making decisions based solely on that, I think, is very important. Another thing is, I think, especially early on, aside from publishing papers and really thinking about productivity and those kinds of things, to me, one of the most important things that you can gain early on is scientific confidence. So it's really the ability to design your own experiments, to have those experiments not go well, but then to come up with ideas for what you could do next that would increase your chances of that experiment providing new insights that can guide you along a path forward. So really thinking about the process and how early on, we have a lot of focus on the end result, like publications and things like that. But what I believe is more important is the process that you start to develop in your mind for conducting research, as well as for identifying what really excites you the most. So this past summer, I have been learning how to surf behind a boat without a rope, as well as I used to golf, and I've been picking golf back up this summer. I mean, I've only done two rounds of 18 holes, but to me, that's picking it back up. I feel like, there's been a number of years where I was just working so hard, just really trying to accomplish things that I just felt I needed to accomplish. And I didn't put enough time aside, I would say, for hobbies. And so maybe that's the one thing that I would change, actually, if I were, had to go back. But now I'm coming to that realization. And so I'm trying to spend a certain amount of time each week or, each month, just, doing things that I love doing and learning things that I want to learn that are outside of my career.